I'll be solving LeetCode 15 3-sum. Given an integer array nums, return all the triplets such that their sum should be equal to 0, and we need to make sure that the indices are unique, so there is no repetition of the same index again. So we have nums now, and I've taken and noted down the first example here, and let's discuss what brute force would look like. So for brute force, I'm going to fix one element, and then I'll fix the next element, that is 0, and then I'm going to check if the sum of the subsequent elements, and I'll take one more pointer here, let's say A, B, C. I'll change the C pointer throughout the list and then check if the triplet sum is equal to 0. So whatever A is pointing and B is pointing and C is pointing, I'm going to check if it is equal to 0. And then once I exhaust the C pointer, I'm going to shift my B pointer to the next one, and I'll initialize C here, and I'll do the same. So this is my brute force approach. That's how every index will be unique, and I'm going to store it in a list of such triplets those are equal to 0. So what is the time complexity? Since we are using 3 for loops, so we iterated the input list for 3 times, so it's going to be big of n cube. And now let's think of some other approach that's not going to take this long. I'm going to fix one of the pointers at the start here, and then I'm going to take a left pointer and right pointer. My idea is to move these 2 pointers, and the start will be fixed, and then calculate sum of start, left and right to make them 0. So now there's no logic for me to move left and right, because if I move my left pointer, I don't know what the next element would be, right? So in order to help this, I'm going to sort the list down. We have sorted nums, and I'm going to fix this as start. I'm going to take this as left, and this would be right. This reminds us of binary search, right? So what I'm going to do is, first I'm going to check if 4 plus minus 1 plus 2 is less than 0. So if it's less than 0, I know that we need to increase our total. So how do I increase the total? If I move my right to the left, I know that there is an element right here, as in next to my 2, that's lesser than my current right pointer. So that's not going to help me, right? It's going to take my value further down. But if I move my left pointer to the right, and we know that there can be an element greater than my current left pointer here, so I have a better chance of moving my left pointer to the right. So what I'm going to do is, if my total is equal to 0, is less than 0, so I'm going to call total as sum of start, left and right. So if total is less than 0, I'm going to move my left pointer by 1. So we can reverse the same. If total is greater than 0, we move right pointer to the left. So we'll come here, because we know that to the left of my right pointer, there is an element lesser than whatever my current right pointer is pointing to. So now I've tweaked the example a little bit. I've added a couple of ones here, and I've changed this number. And now I have initialized all my pointers. Let's see if this yields a solution. So I'm going to add -4, -1 and 5 together, and yes, it makes 0. So if the solution, as in if the total is 0, I'm going to copy my current triplet to an output list, let's say. How do we move forward from there? So we can either move my right or left. Actually, you can do either ways, but I like to move my left. Now, is this going to give me a solution? -4, -1 and 5. Yes, the sum is equal to 0. We can add this to the output again, but wait, the problem statement reads that they've asked distinct set of triplets. So what we can do is, one, we can make this a set and check if this triplet already exists or not. Is another way to do it is to tweak our logic here. So what we'll do is, if we encounter any duplicates like this, we'll skip it. So once we get our solution, we'll say, let's move our left pointer to the right, left pointer by 1, while we encounter duplicates. So this is a while loop, while my left -1 equal to left. I keep incrementing my left pointer. So as long as my current left is the same as my previous left, I'll just keep moving my left pointer so that we get distinct elements. So what's going to happen in this case? I'll keep moving my left pointer until I reach 0. And you may ask, do we ever move the right pointer? No. So we can just move either one of them. Why? It's because we know the list is just this much and we will exhaust it somehow. And if you want it to be more efficient, you can also check if right has duplicates and then move it to the left. But this also works just fine, so I'm just going to stick with this part. I'm going to sort the numbers. I have start, left and right. Yeah, and we need to know the length of the numbers, and I'm going to call this start. My right is equal to n-1. My left is strictly less than right, so it's not left, not left is less than or equal to right. Why? Because if in any case left and right point to the same element, we will have duplicates, so we want them to point to unique or distinct number. First we'll calculate the total. And then if total is less than 0, we need to move our left pointer to the right. If our total is greater than 0, we need to decrease our sum, and we get that by moving our right pointer to the left. If it's not these two cases, then we know that our total is equal to 0, and we need to copy that to our output. So output is a list. How did I know it was a list? I just looked at the example. to append this triplet here. Just to make sure that there are no duplicates and we don't edit it, I have converted this into a tuple. We'll just increment our left pointer, and we remember we need to skip the duplicate, so while left nums of left minus 1 is equal to nums of left. We'll keep incrementing our left pointer, and then we'll return our output. Let's debug if there are any issues. Oh, it says index is out of range. Oh, while left is strictly less than n, and let's run and see what error we've made. Okay, so this is happening because start is always pointing at duplicate elements. So we need to fix that. So if start minus 1, so if nums of start minus 1 is equal to nums of start, we need to skip the for current loop, so we'll do continue. But wait, what about the first element? What about when start is here? So we need to skip that, right? And then -1 would not work. That's incorrect. So we'll only check this if start is greater than 0. Okay, so I'm going to comment these out and submit it. Okay, this is too much. Yeah, here they have incremented the left and decremented the right, and they've used a better condition. For me, if while left exhausted till the length of n, here we know that left should be strictly less than right, so they've used that condition. Yes, this is much better. So they've just used the logic of do-sum, and within the main for loop they've called the function. Yeah, this is readable. This is something that I would use in production. This is good. I learned something new, and I hope you did too. Thank you.